Calc Maxers. Today we are covering the way to calculate kind of areas under this normal curve. So today we talked about, we have the empirical rule, 68, 95, 99.7, but it starts to break down when we have data points that are between two of the z-score, the flat z-score, -1, -2s. So like this data point right here. A song, in this case, we're working with data with the mean as 220, the standard deviation is 26. And so when we have this song and we're finding it shorter than 181, well, 181 falls in between two of these boundaries here. So we're actually going to find the area of this under this boundary without our normal sections that we've been using for 68, 95, 99.7. So if we calculate this z-score and draw our picture, we'll have this area here, and remember this picture has to stop, but really the normal curve keeps on going all the way to -infinity. It never crosses the x-axis, but it gets closer and closer and closer and closer and closer. So what happens is we actually need our calculator to find this area for us. There's not really a good way for a human to calculate this by hand. So we are going to do that today. In your calculator, there's that wonderful blue second key. You're going to go ahead and press that. And then we are going to come to a different key than we've been using. We've been using the stat key, but if you look in the blue text, this says distributions. That's for the normal distribution. So we're going to go under the down arrow and click the vars button. And this will pop up a giant list of all the possible different distributions that we'll be working with in stats class. What we want is stuff that has to do with the normal curve. We don't use NormalCDF a whole lot, so we're going to stick to 2 and 3, NormalCDF and invNorm. NormalCDF is for when we have a z-score and we're trying to find an area. So this is when the area is unknown. So I'm going to press enter on NormalCDF. And I already have the numbers in there. That's kind of awkward. But the lower number in NormalCDF is the absolute left side of our picture. And if we look, we said earlier, this shaded area technically goes on to -infinity. Well, we can't really type -infinity in the calculator. So what you can do is just type in a really, really negative number. Put in a -1 and a bunch of zeros. Put in a -9999999, whatever you need to do. The upper bound is going to be the right side of your shaded area, and that is our z-score in this case, -1.5. Z-score would be right there. So I have that as -1.5. When we are working with z-scores, keep the mean as 0 and sigma as 1, and paste that in. And that is the area. So the area under that portion of the curve is 0.0668. which is 6.68%. If we move on, next we have a song that is 260 seconds. So I'm going to look at that and calculate the z-score of that now. 260 minus the mean in this case is 220, divide by the standard deviation of 26, and this is our new z-score. Now for this one, if we look at the picture, this is everything greater than 260. So when I go into my NormalCDF and I start typing things in, well, now my lower and my upper have changed. My lower boundary, the left side where the lower numbers sit, that is now going to be my z-score. So the z-score was 1.5385. Oops, 1.5385. And now the upper boundary, that goes on forever in the right direction. So instead of typing positive infinity, which we can't do on the calculator, we're going to type in a really, really, really large positive number. Mean stays as 0, sigma stays as 1. Paste that in, and there's our area, 6.2% about. If we look over here, that's what we got using a slightly different method. Then if I look at number 7, this is the other type of problem we can have where we're looking in between two numbers. So we had a song that was 193 seconds, we had a song that was 245 seconds, and we can calculate the z-scores of both of those. So 193 minus 220 divided by 24 is negative 1.04, and then do that the same for the upper side, that is 0.96. When I go into the calculator for that, again, second dist, and then normal CDF. Now, my lower and my upper are not going to be, neither of them are going to be infinity. We've got a lower boundary of negative 1.04 and an upper boundary of 0.96. Mean stays as 0, sigma stays as 1. And that is the area between those 2 points under our normal curve, 0.6823, which is about 68.23%. Lastly, we have this final type of problem. This one, it asks, what would a song length be if it was the top 10% of longest songs? So that's going to give us an area, and now we're looking for a z-score and eventually the actual song length. So we're going to take that area, 0.1, and we're actually going to find the area to the left of that. When we do this, we're going to always find the area to the left of what we're looking for. So if 0.1 is on the right, then 1 minus 0.1 leaves 0.9 to the left. So I'm going to go back to the calculator, second distribution, but instead of going to normal CDF, since I'm going the other direction now, since I have an area and I'm looking for a value, we're going to use inverse norm, which was number 3 on that last page. Our area for inverse norm is 0.9. Leave the mean as 0. Leave sigma as 1. And then this tail, we could customize it, like we could say right tail and leave the area as 0.1. But some people don't have this option, and so it's easier in class just to everyone leave it as left tail. Paste it in, and that is the z-score of what we need. So we're going to write down that z-score, about 1.28, and then I'm going to do my z-score formula in reverse. So instead of subtracting the mean, then dividing by the standard deviation, I'm going to multiply by the standard deviation, and then add the mean. So 253.3203 seconds would be the length of the top 10% longest song. So in that way, we've got 3 different options plus the inverse norm. We could have a less than question. Remember, you start at negative infinity, go up to x. You could have between x1 and x2, and we could have x and greater or z's. Usually we use z's for these. And we could also take an area and find a missing value. Last thing I want to note before I leave here, where'd my page go? Right here. Sometimes with normal CDF, we can get really, really small numbers. So like, let's say I do -6. I calculate my z-score as a -6. And I find everything less than -6. Well, a z-score of -6 is pretty far outside the mean. So when I paste this in, we're going to get this strange thing, and maybe you look at your calculator and like, oh, that doesn't look right. So what your calculator is doing here, this is called scientific notation. And maybe you've seen scientific notation before, written as something like this, times 10 to the -10th. That's the same thing. All the calculator's doing is instead of writing out times 10 to the -10th, they just write an e. So what this means is we could take this decimal point here And since it's a negative 10, we could take the decimal and move it 10 spots to the left, which actually means we're going to add 9 zeros in front of this leading 9. So if I put in my decimal first, 0 point, I can add in 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, before I get to the digits that the calculator actually gave me. So the area from negative infinity to negative 6 of the standard normal curve is 0.00000000000999012. So very, very, very small percentage of the data is in that area. All right, I hope that helps. I will see you next time.